Hello to everyone. My name is Joshua Flood. I'm a co-founder and director of Maritime Research at Valour Consultancy. I just wanted to welcome everyone to our online series of presentations looking at the impact of 5G in maritime connectivity services. And this online series is organised by the BS Group. So it's the adoption essentially of 5G technology and the potential to revolutionise the shipping industry by providing faster and more reliable connectivity. So 5G can enable new applications and services that improve the efficiency, safety, and customer experience. So today's online presentations are going to include myself, and what I'm looking to do is explain the ecosystem and the industry nuances of why 5G is so important, particularly to the players. Then my two fellow peers, I've got Pablo, who's a director at CNIT laboratory at the port of Livorno, and his presentation will be looking at 5G for autonomous shipping. And then I have Kris, who is the head of technology and logistics at P&O Maritime, and his presentation is the impact of 5G and LEO on maritime operations. Just a few housekeeping rules. If everyone could keep their mics on mute, we have quite a number of people attending the presentation. Each presentation will be approximately 20 minutes, 15 minutes of the presentation deck, and then 5 minutes for Q&A. So please ask questions. It makes it so much more interactive and interesting. And also make sure you don't ask me too hard questions. Okay, I'm just going to switch over to my presentation deck. If everyone could just bear with me a second. And yeah, so it begins. So the future of maritime connectivity, 5G, and how it fits. So essentially what I'm trying to do here is I want to provide a lay of the land for maritime connectivity and understanding the players, the companies, the nuances of the relationships of who's doing what and how it will change. So just giving a quick 45-second update on who we are, who I am, and what it is. So I'm one of the co-founders of Valour Consultancy. I set up the company with two friends in 2012. I'd like to say in terms of we're inspired by Usain Bolt winning 3 gold medals at the London Olympics. However, he's had one taken off him now, and I try to refrain from using those analogies. But we're headquartered in the UK, and we also have offices in Australia, or a company in Australia. And our entire mission statement is to examine, review, dissect, evaluate, and extrapolate connectivity solutions for the mobility sector. So we're focused on aviation and maritime, but we're also looking and exploring new applications such as land mobility, the government. We have a team looking at smart enabling technologies in airports and ports. And our services range from like syndicated reports, bespoke custom research, surveys, and white papers. And like these types of key questions that we look at is like, what is that addressable market? How fast are technologies or solutions progressing? Who's working with who? What are their strategies? What perils could befall certain players in the future? How do different products compare? What is the best for me or for you? And yeah, we've been going pretty well. So we've been active for 10 years. 2020, we won a Queen's Award for International Trade. And about 3 months ago, we won a King's Award for International Trade. So we're doing something where we're probably quite good at winning awards. So just going over in terms of the objective of my presentation. So it's really to encompass 6 key factors: who those key players are, how things have traditionally worked, how the impact of 5G and LEO services have changed company strategies and end user perceptions and expectations. So what is that market now? What is the market share of each technology, each solution holds, and what is that commercial opportunity? And what trends will we see from the impact of 5G and how will companies use the technology to gain a stronger position? And then I'm just going to provide a little bit of conclusions, key takeaways, and further ponderings. Just as well to provide a little bit of notes on the picture, I was recently watching Elton John at Glastonbury, and he inspired me so much with his performance. I decided I'm going to try and relearn some Elton John classic hits. Just one caveat, I need to say, they're not my hands in the picture. Okay, so how it fits. So right now you can see a big array of companies, or more specifically company logos. So in your top tier, you've got all the big service providers, and it's a selection of the companies. It's not everyone I'm going to say. So you've got Marlink, Speedcast, Immersat, Navarino, NSSL Global. Then in the second and third tier, you'll be able to see your mobile operators, your telcos. Then you have your L-band providers, which are companies like Immersat and Iridium and a few others. Immersat's just been recently purchased by Viasat, and that deal was completed at the beginning of last month. Then we have our traditional MEO and GEO providers such as SES, Intelsat, Eutelsat, and others. And then we have our new people on the block. So this is our LEO providers of Starlink, who've been offering their solution since July last year. OneWeb have just started their commercial launch in the beginning of last month. We have coming up solutions from Telesat and Amazon Kuiper. So it's an extremely fragmented market. And one of the things that I want to just move on from a cellular perspective, one of my initial assumptions when I started writing or covering the cellular market was I assumed the maritime satcom companies were responsible for the bulk of sales for cellular technologies. And that assumption was completely wrong. The bulk of the big end users are reaching out to the telco companies themselves, mobile operators, or going via unique wholesale cellular experts. But they tend to sell, I'd say, a bit more to the smaller service provider and niche markets. But it's incredibly fragmented as well. Whilst interviewing one of these cellular experts, they informed me, they're like, Joshua, this market is split into 3 key points. There's cowboys, those who are commercially naive or sneaky, and the real genuine experts. And I assume he was meaning himself to be the genuine experts, and alluding to service providers being a bit naive or sneaky with the cellular contracts. So it's almost pick at your peril. Now, one of the things that I do in my role is, as well as interviewing the service providers and the satellite operators, I'll go out to the end users and I'll speak to your technical op guys, your IT managers. And it's a lot of the time I'm verifying what gets released in a press release or in an article saying we now are using this company's connectivity service or that company's connectivity service. And I'm just trying to understand is this correct? Why are you using them? What's the parameters of that decision? Is it based in terms of quality of performance? Is it cost? Is it other perceptions? All the perceptions. And I'm trying to also understand the perceptions of the other service providers. So in a case recently, or probably about a year and a bit ago, I reached out to a North American tug vessel division, and I found out that all their vessels were only using cellular capabilities 4G with the Canadian telecom company TELUS, which ironically isn't on my presentation deck, say la vie. But essentially, they had this pool deal covering all their fleets. It cost about 10,000 Canadian dollars a month, and it equated to about 2 terabytes of monthly data. But what I've since discovered of interviewing a lot more people is a lot of the big end users are using these big data pools across their entire fleet. And it's pretty similar, I always think, to the passenger vessel market, particularly ferries in Europe. For SATCOM, and this is the only exception I would say is the larger cruise vessels. What else has happened is with the new LEO players that have come in, it's completely changed the game. The market has become thirstier for greater data bandwidth, and margins are being squeezed and changed expectations of end users. So some of the service providers, previously, they're making 20-40% markups on their GEO VSAT services. Now with some of the LEO services, there isn't a markup. It's 10-20% maybe if they can include an integration or a management fee. And this is placing enormous strain on maritime service providers. So just going back to conversations that I have where I will reach out for our tracker service to end users. I was speaking to, I'll say, a global merchant container ship company. And I was speaking to the person responsible in IT for them recently announcing they were using Starlink directly. And they had 2 incumbent service providers. And I was asking that person, look, what type of reaction did you get from these service providers once you announced this decision, and how are you going to integrate the solutions, and what are the parameters that you need to think about? And the person was like, well, I actually brought them both into my office. I'm not too sure if they were together or simultaneously, and started the conversation with, have you ever heard the story of Blockbuster? And I was just like, wow, that's such a bold statement to make two of your incumbent service providers. There's so much tenacity there. And I suppose this has shown how much things have changed over the last 10 years. So previously, cellular and SATCOM have played a role of to and fro in the relationship. When the vessel's near the coastline, the vessel will use cellular connectivity and will also use SATCOM. However, LEO services have completely now changed that perception, and people are expecting this ultra-fast bandwidth connection all the time. So in another case, a yacht owner he'd been on a GEO VSAT service. He had 4 megabits per second downlink, 2 megabits per second uplink, and he'd been on the Starlink plan for 2 months. And then he was complaining to the regional service provider, I can't believe my service is only 150 megabits per second today on the downlink. And the service provider was like, two and a half months ago, you were only on 4 megabits per second down and up. And it just shows you now, people now expect much faster bandwidth, but at the same price. And this is alluding to the point, this is a huge dilemma for some of the larger service providers and also the geo satellite operators. And what's happening is the service providers are having to respond to help their customers, but in fact, it's depleting their bottom line. And look, they have been preparing for this for some time. We've seen the offerings of hybrid connectivity solutions, the drive of SD-WAN technologies and platforms. However, some of their cellular connectivity solutions have been crude and too simplistic. And the service providers are almost having to pick their poison. Look, we're either going to have to start cross-selling lots of different connectivity services to make up for this loss in profit margin. We sell more value-added services, or simply we're just looking to extend contract deals to create more customer stickiness. And this is what really, in terms of where 5G presents an opportunity to augment their cards. So I just want to lay the land here and show you in terms of my breakout by the different connectivity services that are provided in Maritime. So there's 3 key points here. I know there's lots of big segments. Large numbers don't tell the whole truth. What can start small can grow much quickly than previously anticipated. And I actually had no idea the LTE cellular equipment market was that big. However, I will caveat it and say typical contract values per vessel or across the vessels are much lower than VSAT SATCOM. And obviously, there's limitations on the cellular capabilities and on the vessel's distance from the coast and what they can charge. And there's other parameters that go into pricing in terms of supply and demand and the cost to produce a service. But anyway, I'm just going to go into the components of this chart. So if you look at the L-band market or MSS market, there's approximately about 80,000 vessels globally with this technology. But what you will find is typically there'll be multiple terminals on the larger vessels. So you can split this market into your low-speed data and no voice. And a good example of a low-speed no voice would be your Immersat C terminal for GMDSS. And this is like a low monthly subscription, probably the equivalent to like a consumer phone contract. Then you have your higher L-band, like Fleet Broadband and Certus. There's roughly about 44,000 vessels with this technology on board. But give or take, there are some varieties to these solutions and how they're incorporated into VSAT that people should be aware of. Then you've got your Geo VSAT service. So by the end of this year, we think there'll be about 48,000 vessels split across those service providers of Marlink, Speedcast, KVH, Navarino, NSS Global. There's a big long list. Then you have Immersat Solutions with its direct go-to-market solution of FX. You've got SES now, which are going direct, and you've also got JSAT Sky Perfect. And then if you look at the cellular component, so of that 42,000 vessels, you've got 20,000 that are leisure vessels, 2,000 of each which are offshore energy and passenger carrying vessels, about 10,000 are merchant vessels, and you have numerous thousands of fishing. But one of the points I wanted to explain is, so you have this new emerging sector of LEO, and this is Starlink basically since July last year, and now you've got a small number that have come in from OneWeb in the last month or so. And it has grown so fast, it has astounded me. I would actually almost refer to it almost as a bull run in financial speak. People would ask me about this 24 months ago, 2 years, and I would make a comparison of like how the LEO providers and compare them to Inmarsat FX solution when it was first launched in 2016. The speed of adoption has been incredible. And I'm just going to get further on about this. So just this side is quite self-explanatory, and it's just explaining. So ARPU is average revenue per user or per vessel. And it's just following on from those components that I mentioned on. So with the L band, with a low speed, that's about $60 a month someone would pay. For fleet broadband, that number would be about $600. Then with your Geo VSAT FX, you're looking, with your Geo VSAT, with Inmarsat's FX services, depending on the committed information rate, you're looking at about $2,000 to $2,500 per vessel. With the KU band, it's about $2,500 to $3,000, and the C band is $10,000 sometimes per vessel. It can be even higher. But I will say there's very few vessels in the market that have C band equipped on there, and it's sort of a, I don't want to say a dying section, but it's a much smaller section. It's not in terms of previously well used. Then we have our VSAT LEO model, and this is predominantly based on Starlink's model, the $250, $1,000 or $5,000 data package deals. I think what you're going to start seeing is with OneWeb, they're going to start introducing similar pricing, I think, to the Geo VSAT, but it's going to be based on the profiles of the vessel type. So in terms of this is what a container vessel would typically use. So it's going to be priced at that, but with a much higher committed information rate. And then in terms of the cellular market, it's very fragmented. You've got a cross of data pools, you've got pay-as-you-go deals, and you've got deals that are going through the service providers. And this could be, so for a data pool, it could be $2,000 to $10,000 a month, depending on the data package that you get and how big your pool of vessels are, to an ongoing vessel by vessel pay-as-you-go basis, which is $250 to $1,000. So the key point of the question, so why is 5G going to become so prevalent? And so my take is this. So there's many enablers for faster connectivity: real-time information, video calling, streaming communication, crew health and welfare via telehealth services, potentially unmanned support operations such as drones, which I think will get spoken about later on. However, vendors in the connectivity sphere are now realizing the importance of full turnkey solutions. And vendors I'm talking about in terms of the service providers. For years, customers have complained about connectivity congestion in ports, and 5G is going to provide a key component to remedy this problem. And by providing these solutions, it's going to provide better customer retention. So just getting to the conclusion of all my points, yes, 5G will provide even faster connectivity. And if within range, it's going to be potentially 10 times faster than LTE and likely 2 to 3 times greater than LEO services offered in the maritime realm of ports. But the main critical differentiating point between 5G and, say, LEO services is that high-speed data 5G technology in ports. And where ports get particularly congested, users will receive a subpar experience. And you could probably actually make some comparisons. You're already hearing in certain regions where the price, the take-up of LEO services in certain regions is causing speeds to plummet because the constellations aren't suited to dealing with that type of congested field of traffic. So ultimately, such speedy connectivity hopes to enable real-time, accurate information. This is going to encompass many potential applications, and my fellow peers are going to talk about this in greater detail better detail than I can. But this could help aid in logistical information from a vessel, crew, or passengers. And companies such as Inmarsat and other service providers will likely really embrace the technology to strengthen its hold on its customers. And you can see already with Inmarsat and its FX customer base of 15,000 vessels, it's probably a little bit bigger now. They're all going to include cellular capabilities within their packages of Fleet Reach. And this was announced last month. And you're going to see lots of other service providers doing this as a tool to try and keep hold of its valuable customer base. So I'd say my final points are there's going to be some different varieties of 5G, and it's about understanding the modes of bandwidth for each, which will vary. And there's also, in terms of a point to take with me providing this holistic view of how many different vessels there are using certain technologies, not all the commercial merchant shipping fleet will be suitable for the technology. Fantastic. Well, that's come to the end of my presentation. I'm just going to see if we have any questions. And I don't think we do. Fantastic. Paolo, would you like to start your presentation? I think as well, I've hit the 2:20 mark perfectly.
Thank you, Joshua, for the introduction. Let me share my screen. Okay. So I will talk about 5G in a specific vertical that is the one related to unmanaged shipping. Myself, I'm a researcher. I'm head of a research sector at CNIT. We'll introduce shortly what the CNIT is. And I'm also leading a laboratory that is specialized in maritime. This laboratory is located in Livorno. Livorno is a port in Italy, a historical port in Italy. There will be some comments in relation to Livorno in the following slides. So let me introduce CNIT very shortly, 20 seconds. So is the National Interuniversity Consortium for Telecommunications, encompassing 41 universities, and it is specialized in technology transfer. In Livorno, we are actually doing our business since 2015. We have framework agreement with both the Port Authority and the National Coast Guard, actually dealing with the land side and the water basin. And we are part of an innovation center that is actually also encompassing the Environmental Protection Agency and other business and research centers. So we are doing innovation in 4 verticals. One is related to vessel and marine navigation. Another one is about intermodal logistics, also passenger transportation, and specifically mobility as a service, and sustainable growth. So what I'm talking here is about the autonomous ship. I will first try to set, I would say, the scene with the regulatory framework that is in progress. And then I will talk about the project, I would say, an initiative that is funded by the European Space Agency under the supervision of the Coast Guard in Italy, and this initiative will have a trial in Livorno. So let's start with the background and motivations. If you see this cover page is a bit dated, is from 1964, 9th of March. So you see that autonomous ship is not, how to say, a recent buzzword, but is there since quite a while. Now the ships are turning more and more autonomous. We have unmanned surface vessels that are the ships of say smaller dimension, and also maritime autonomous surface ships. The acronym is MAS. They are now showing up, especially in the Far East, in Korea and Japan, but also in Europe and the northern countries like Scandinavia. You see in here the classification of autonomy for ships starting from level 1 to level 4, and there is also a gray, region, level 2 to 3, where there is some autonomous operations, but people can, stay on board or eventually can control the ship. So why are we dealing with the autonomous ships in the world? Because we want, to eliminate needless voyages. So there are actually targets in relation to environmental protection, but also we want to reduce logistics costs. We want to have less incidents at sea. We want to, promote cooperation with shore-based operations, and especially, as I said, logistics is in the scope of autonomous shipping. There is, as Joshua mentioned a few minutes ago, an increased attention to logistics. This is the steady growth of the international trade in the maritime business. You see that is always growing, apart from some artifacts related to the pandemic, and you see that also there is a growing investment in unmanned ships. The biggest part, the largest part, is about remotely operated ships. So in the regulatory bodies, most notably the International Maritime Organization that is based in London, it's an agency of the United Nations specialized in maritime. We are dealing with digitalization of the sector. So there is, the innovation related to this seamless exchange of information from the seaboard to a shore-based center. What do you want to exchange? Actually, you want to exchange maps, you want to send alerts, have real-time, long-lasting connectivity from the vessel to the shore. And also, apart from IMO, also this non-NGO, this non-government organization, this IALA, this is the International Association of Lighthouse Authorities, is also playing a role in that regard. So what are these bodies drafting these days? They are drafting a mass code, so an international treaty about unmanned shipping. And this is going to be released by the end of 2024 and eventually adopted by 2025 as a voluntary code. And then the normative counterpart will show up just a few years later. And so I try right now to sketch gap analysis towards the possibility of having unmanned ships in our ports. So the first is the definition of the degree of autonomy. So when the ship is intended to sail fully autonomous, or it is assisted somewhat by an operator. And there are a lot of, results in the literature and scientific literature, especially because, of course, these conditions depend on the environment on one side and on the expected functions that is being automatized on the other side. And you can even look at these references. There was a regulatory scoping exercise ended in 2021 at IMO, and this actually provided with some results in relation to the onboard equipment that is expected to be installed on board, and also the assets in terms of sensing, in terms of med stations, and also connectivity infrastructure that is expected to be at the port side. And an operator that is intended to be a seafarer, so part of, if you like, of the bridge crew, is staying ashore and will check and monitor the autonomous ships in all phases of navigation, including the maneuver nearby the ports. So this new navigation systems will allow the ship to approach the port, will perform a real-time calculation of sufficient manning, eventually asking some safe fallback of the control, and of course requires reskilling of maritime operators, so especially pilots that are the skilled personnel of the ports. So you see that maritime services, they need to be standardized. This is a snapshot of a loop that is from CMA CGM. You see connecting the Northern Europe with the West Indies, and you see it is expected that this single vessel is not experiencing a lot of different interfaces, but the same ones in Europe and in the United States. So we need to digitalize the ship, we need to digitalize the remote operational control and the network infrastructure, but please, let's do these things in a standardized way. Finally, as I said, there is a growing interest on the aspects related to environmental protection. This is an image for illustration purposes only, please. In front of the coast of Livorno, you see that there are a lot of dots where the ship is waiting for the entry slot in order to approach the port and berth. And this is west of fuel, this is the west of working hours for seafarers, so you don't want to experience these things, you want to reduce such kind of effects. And with autonomous shipping, of course, we will be enabled to minimize the ship cycle, so the time used by the personnel to unload and reload the ship in the port, to reduce consumption, the staff working time. So it will be possible to release services related to just-in-time arrival, berth pre-booking, customs pre-clearing. All these things are services that are actually going towards the direction of reducing the impact, the environmental impact to ports. So how to implement, how to fill this gap that I actually tried to sketch in the previous slides. You see, the challenge number one is to be capable of having a hybrid network. Probably Joshua also mentioned about it, because he mentioned about the lowered constellations, low Earth orbit constellations, and the 5G. There is an effort at 3GPP towards the last release of the fifth generation of mobile networks that is going towards the alignment and the integration of terrestrial and non-terrestrial networks, most notably those coming from the satellites. And also there is actually a study that was triggered by Ayala in relation to unmanned surface vehicles. So we are talking about ships of not large dimensions, not large size. So challenge number one is to connect in a hybrid way the network from the terrestrial and non-terrestrial domain. Second one is to implement a digital infrastructure. So this is a slide coming from a dear colleague of mine. You see the evolution of ports from the ancient ages to the port of the future. The buzzword is that of being being large. So what does it mean large? To be lean, it must be transparent, not to put too many obstacles, agile, resilient, and green. So this is the port of the future. To accomplish this evolution, you need a cyber-secure digital infrastructure. So as I said, we want to have seaways connecting the perimeter of the port to the berths in a seamless way. Most of the ports we are now undertaking a process to implement a non-public network, so a standalone separated terrestrial network, and of course also the cybersecurity counterpart in terms of, as I said, be safe in respect of threats. For the remote operational centers, we want to have secure communications. There is a standard that is growing these months from IC, but also we want a safe fallback of control if connectivity goes down. So you need somebody in charge from the ship to take control. And data management, all the issues related to trustworthiness, irrevocability, mutability, time reference, manipulation with history of transactions, privacy must be taken in the due account. And when I say all this, how to say, keywords, of course, I'm talking probably of distributed ledger technologies, so blockchains in the port infrastructure. And then we want to have, how to say, we want to secure the list of maritime services that will be offered by all the ports. As I mentioned, the loop from North Europe to the West Indies, we want to have the same services provided by all the ports. Otherwise, the market will not, how to say, grow so quickly. So, for instance, you want to have real-time vessel tracking and monitoring. You want to develop a plan for operating the vessel. You want to implement vessel collision avoidance, vessel arrival slot management. So there must be, how to say, a standardization of the maritime services. And of course, these services will be implemented atop a remote operational center like this one. And the Belgian delegation has actually submitted to IMO the idea of how to design such an operational center, and you can even consult it. Myself, I tried to have the list of DAX services in this publication. Just a few words very quickly about what we are experiencing in Livorno. Livorno is the door of Tuscany, is the coast in front of Florence. Florence is known everywhere in the world. From the logistics perspective, it's a historical port managing both passengers and freight. So we have cruises, but we have also container ships. It's multi-purpose. We have a freight village in the surroundings. It's located, you see the blurred image as a background. It's located along the Scandinavian Mediterranean corridor connecting north to the south of Europe. Why are we famous? We are somewhat famous because of Ericsson, because Ericsson actually calls me a trailblazer of 5G imports. I'm honored of that. We started the first trials in 2017. Now we have a master plan considered in the next years, and we have been the first testing, to say, the industrial bands for 5G connectivity and non-public networks in ports. Now, what are we doing? We are starting a program with the European Space Agency in relation to uncrewed shipping, with the objectives of integrating what is running on board and what is running land-based. The prime contractor from the industrial consortium is Telecom Italia, so we have a career of the 5G, and we are working under the supervision of the Italian Coast Guard. The trials are expected early next year, end of this year, early next year, 2024. So what are actually expecting the end users? So you see in these cartoons, I consider the port authorities, I consider the lines and the pilots and the Coast Guard, actually a 24/7 port, fully digital on one end, then the feasibility of the unmanned shipping in historical ports on the perspective of the Coast Guard, but also the possibility of communicating with the port. So don't think of, how to say, full-fledged, fully autonomous ships. They will come afterwards. Now what they are targeting is to access reliable data sets, have a fully aware consciousness of what's going on the water basin for the maneuver, and actually this very good link provided by 5G for having communication with the port. So this is a tower with the 5G millimeter wave non-public network with localization and bidirectional broadband communication. This is an animation related to the approach of the vessel to the port. You see how tiny is the port of Livorno. It's a historical port from the 16th century, so there is no lack of continuity between the port and the urban settlement. And this is the prototype of our shore control center. So we have nomadic equipment, we have fully aware track control, and we have these, how to say, computers with the 5G core network installed nearby to permit this communication with the vessel. So let me drop my conclusions. I actually probably talk too much. This was about, how to say, a managed shipping. It is a comprehensive full digital domain that how to say, encompasses international regulations but also technical development. It will be legally viable starting from 2025, so be ready for that, because they have to say vessel can pop up in your ports, and you need to serve them. And in order to check the readiness of your harbors, you have to consider the challenges in the network architecture and performance, the layout itself, the remote operational center functionalities, and finally the end user services, and in order to check whether they are matching their expectations. So Italy is on the forefront of this innovation, and we start from Livorno, that is a historical port and is setting a couple of issues and concerns.
Paolo, are you able to answer the question from Surendra? So ships are metal boxes, and the Faraday cage effect has made wireless connectivity in a vessel challenge. IoT struggles without wireless. Is there a program in space in this space using 5G antennas to eliminate cabling and facilitate real-time data collection?
I know. I followed your question. Is it possible to have it displayed? But I know that there are cruises now, passenger ships, where even 3,000 sensors are connected wireless. And of course, it's a cage, as the attendee is suggesting, but we are collecting information from the inside, and then you have point of communication atop the vessel. So, of course, it is not fully meshed because of the barriers coming from the metal of the surface in the hull of the ship, but you can, how to say, reach the signal in another way. So if that was the question, of course, this is easing the job of everybody. There are also container tracking devices that are now being developed, glued on the, how to say, on the containers, and you can reach them with line of sight from the satellite, of course.
Thank you very much, Paolo. Really appreciate that presentation. Kris, would you like to start yours? I realise that we've encroached over by 3 minutes, and apologies for that. My job as a bad moderator.
No worries, I'll try and keep mine to the point. Okay, so good afternoon. My name is Kris Vedat. I'm the Head of Technology and Logistics at P&O Maritime Logistics. And today I'm going to discuss the impact of 5G and LEO technologies on the maritime connectivity from an operator's point of view. So just first, a little bit about P&O. So P&O is a vessel operator. We operate and own around 400 plus vessels globally. P&O itself is a very traditional shipping company. It's over 185 years old. It was born in 1837 in the UK. We employ around over 3,000 people globally, and we have around 52 nationalities working for us. So we're a very multinational company and very global organization. P&O is focused in 4 distinct service areas. So we have our offshore division, where we provide offshore support services to the oil and gas industry and to the renewable industry. We have our offshore logistics division, which I also head up, where we are providing integrated logistics to the oil and gas industry using technology to optimize cargo delivery to all of our clients. We have our ports and terminal services division. They provide terminal service operations like towage, pilotage and mooring to terminal operators globally around the world. And then we have our cargo transport division, providing cargo service, traditional cargo services, moving cargo, specifically larger cargo modules, point to point for our oil and gas clients. So today I want to talk about 5G and LEO, as they are very disruptive technologies, certainly in the marine industry. And just as sort of a starting point, I just wanted to kind of touch base on what is 5G. So 5G, in effect, is the 5th generation of LTE. So it's the latest iteration of the cellular network technology. As my previous colleagues or peers have mentioned, it provides faster data transfer speeds, up to 100 times faster than 4G, as well as lower latency, which is obviously then providing a better connectivity. LEO, or low Earth orbiting technology, which is very new, is very different to your GEO and MEO technology, as it's lower Earth orbiting. And due to its proximity to the Earth, it provides lower latency communication. And as a larger constellation, it can provide a greater coverage of the Earth's surface. And with the higher frequency bands, it enables larger amount of data transfer as well as higher speeds. So in essence, 5G and LEO satellite technologies are shaping the future of digital communication, providing greater and more faster speeds and more reliable connections than we have previously seen in the marine industry. So there are some obviously challenges with 5G and LEO, but obviously if they can collaborate in a hybrid model, they can work very well together. So 5G works very close for short connectivity, whereas your LEO satellites will work in greater deep sea operations. Together, you can look at a redundancy in place, which improves the connectivity and reliability. And we're using sort of SD-WAN technology. You can utilize automatic transitions between the 5G and the LEO satellite network on board to try and provide an uninterrupted connectivity. And with this new bandwidth that we have in place now and the greater speeds, we can empower such things as IoT applications far greater on board the vessels. Real-time vessel tracking becomes easier, smart navigation, and as Paolo mentioned, autonomous shipping will become more and more accessible due to this enabling technology. And very importantly as well, crew welfare becomes far greater, because with the greater bandwidths on board, we can provide this to the crew on board, which enable them to communicate easier with their friends and family, as well as to benefit from greater technology services like live streaming TV on board the vessel. So in essence, combining the strengths of 5G and LEO technologies, it can revolutionize the maritime connectivity, driving efficiency, safety, and innovation in the sector. There are some challenges with implementing this technology. So there are some tactical challenges. So the marine industry operates in harsh environments, and this can degrade the signal quality. You know, sea salt, moisture, rough weather can have an impact on LTE technology and LEO technology. There's interference potential with other satellite systems. LEO technology is very new, so there are still a lot of untested scenarios in place yet. So we have to be very conscious of this to ensure that it doesn't interfere with existing systems on board. Integrating this can have some challenges. So the seamless integration of 5G and LEO technologies with existing maritime systems can have challenges, and we need to be aware of these. And at the moment, we're not 100% sure on the coverage and capacity. So at the moment, for example, LEO technology, yes, Starlink seems to be the predominant player in the market to date, but the capacity challenges that it will come across as it starts to expand is still not clear. So we need to be very aware of that as well. The non-technical challenges, so we still have some regulatory issues in place. So LEO is not approved in all locations globally at the moment, so there is still some regulatory challenges that are coming about. So this needs to be taken into consideration when the deployment takes place. Obviously, security concerns are always front and parcel of all of our issues that we have. Cybersecurity is such an important factor on board the vessel. With these new technologies, we need to be very vigilant of these, and there are any new challenges that we need to be taken into consideration. There is some cost involved. Obviously, the airtime cost is reduced, but there are some implementation costs that need to be taken into consideration. And there is a change management on training that needs to be put into perspective. Obviously, with higher bandwidths, the various technologies on board the vessels will increase, and we need to ensure that there's the change management in place in order to accommodate all of this with our crew on board. Communication has been evolving for many years. If we go back to the early 2000s and the late 90s, we had SAT-C in place. Then email became more dominant on board the vessels. Internet became part and parcel of day-to-day life on board the vessel. Then from a crew welfare perspective, social media, video calls, we've started to incorporate IoT, and then live stream TV with Netflix and Amazon Prime and future technologies. All of these technologies are dependent on lower latency and higher bandwidth. So technologies such as LEO and 5G have enabled these technologies to become encompassed into the day-to-day operations of the vessel. But with the increased demand for communications on board the vessels, current technologies need to advance. LEO has been very disruptive, and it is taking on this demand, but we still need to ensure that we're progressively advancing in this area. Because as we know, the demand on bandwidth and communication will only increase year by year. I think COVID certainly advanced that and ensured that the need for online communication and greater bandwidths was certainly a must now. New technologies like 5G and LEO need to become part of the vessel's infrastructure, and our vessels need to accommodate this technology and be ready for it. And as an endpoint, the maritime industry has not really embraced this thus far. It is adopting it very quickly now, but I think the incumbent communication partners have been very slow to adapt this and evolve. So technologies like the LEO have forced traditional satellite operators to adapt and accommodate this technology. And why is communication so important? If I look at the operations of the vessel, I now know why it is becoming far more important. The global data sphere is changing. Data is becoming far more important in our day-to-day operations and day-to-day life than it ever has done before. To date, the majority of the data that is generated is a consumer-based generation. Moving forward, by 2025, it's predicted that 60% of the data that is generated will come from the enterprise, such as technologies as IoT technology, sensor technology. All of these various data points will start to be generated more and more by the enterprise. And as we see, the amount of data that will be generated annually is increasing dramatically. It's predicted by 2025, there will be 175 zettabytes worth of data being generated annually. So to try and put that into perspective, 1 trillion gigabytes is 1 zettabyte. So in a little over 2 years, this is where we will see the amount of this will be the amount of data that will be generated annually. And we need to ensure that we in the marine industry will be able to accommodate this amount of data and be able to transmit this amount of data, certainly from the vessel, because the vessel will start to generate far more data as we start maturing. Because we now work in what I define as a connected model, yeah? So the vessel is far more connected today than it ever has been in the past. We have vessel data being generated, fuel consumption being generated, planned maintenance data. We have sensor technology being generated and passed back to the shore side for analysis. We have crew data being generated. We have cargo data being generated. We have crew welfare expectations. So all of this data is being generated daily, and it's only increasing. So we need to make sure that the communication technology grows at the same pace. And why is this data of value? Because data is key. Using data, we can unlock value for operations. Be it that we start looking at health and safety data in a more detailed manner. So we can start looking at the number of incidents on board the vessel. We can start looking at the most commonly injured parts of our crew, so we can actually have targeted safety campaigns that add value. We look at the maintenance on board the vessel. Can we move into a more predictive or condition-based maintenance model? And we can start looking at optimizing routing, cargo delivery by using real-time data. And I'm going to talk about a few of these examples in more detail now. So using data, we're able to look at the crew performance, to look at some of the challenges our vessels are having, to actually use data to actually derive whether the crew is performing well, whether there is training issues on board, whether there needs to be improvements in the master's management of the vessel. Whereas we don't start penalizing a master who takes on challenges, but actually looks at the data to actually see how well that crew is performing, and whether there is any need to improve some of the training conditions on board or some of the vessel conditions on board. We look at how they're performing their day-to-day work to make sure that they're operating efficiently, benchmarking them against other vessels in the same area so that we get a better view of our crew and how they're performing on a day-to-day basis. We look at fuel consumption data. Sustainability is such an important subject matter nowadays. So how we operate our vessels and how efficient we are of our vessels has become far more important and essential, and in effect a license to operate. So taking real-time fuel consumption data, we're able to monitor the vessel, we're able to track the vessel's movements and ensure that they're operating in a fuel efficient method and manner, and providing that assistance to the vessel to be able to guide them on their journey, on their routing, to ensure that they are operating the most fuel efficient economic method, using data to provide that decision and guidance. Another technology where I mentioned IoT technologies, which has been greatly adapted nowadays, and with greater improvements in speed of communication, we're able to use this in far greater detail and far more accurately. So one example is we have an IoT technology on board our vessels called Vitalix, and this is designed to look at the vessel's lube oil in a real-time manner. So it's taking real-time sensor readings from the vessel, from the lube oil, analyzing that data, and then looking at providing predictive alerts for any issues on board. In this instance, what we had is that there was water dilution on one of our vessels. This is a real-life case study. Water was entering into one of our thrusters. So we got an alert in our system. This is obviously from the data from the vessels. We could see that this problem was increasing, and despite us trying to increase the amount of lube oil into the thruster, it wasn't having a positive effect. So we knew that we now had to take corrective measures in order to rectify this. So then we replaced the cooler, we replaced the oil, but this didn't actually then have a positive effect because there was water still within the system. So we needed to fit deabsorbers. So deabsorbers were fitted. We could see once the deabsorbers were fitted that this had an improvement in the amount of water dilution, but not sufficient. So we had to fit another deabsorber. With the second deabsorber fitted, we were able to reduce all the water from the oil and the vessel was then able to move in, was able to continue without any issues. With this, we were able to avoid a very costly dry dock because we had to have taken the vessel out. The thruster would have had to be overhauled. It would have had a 7-day dry dock, and we would have had 10 days loss of revenue, which would have had a total cost of $620,000. Using the IoT technology and the communication on board, we were able to mitigate this challenge while still at sea without having to take the vessel out of service, and had a cost saving around $550,000. So that was a very practical example of how a combination of technology and communication can improve maritime operations and become far more efficient in our day-to-day working. To sum up then, so the impact of 5G and LEO is having a major impact on the speed and the communication on board the vessel, but also the technologies that we're able to deploy on the vessels. As you mentioned, it will be able to support autonomous shipping, live video streaming, remote control operations, demanning operations. So with this, we're able to improve our operations on board our vessels and become far more efficient. Thank you for listening, and happy to take any questions.
Just seeing if any questions come through. Okay, so I've got one here. Shall SSAS, ship security alert systems, can they be connected to 5G instead of using old school IMASAT-C? Do you want me to repeat that again, Kris?
No, so I think that's a regulatory issue, if memory serves me correctly, because at the moment, from a flag perspective, you need to use the SAT-C terminals in order to be able to comply. So I think one of the things that I could be wrong, but I'm pretty sure it's a regulatory issue. I think one thing that is clear is that flag and class probably need to ensure that they're becoming far more aware of these technologies that are coming into play, and to start to change the regulations to adapt and adopt to the new technologies. But I think also one of the things is that from a 5G perspective, it's only as good as 40 kilometers from shore side. So whereas the SAT-C terminal is a globally connected network. So I think I can see why it wouldn't be at this point, but obviously with the technologies like LEO and other things come into play, it could be something that we need to look at to avoid that costly SAT-C terminal.
Could you ask Kris as well? Could you answer this question? It was aimed at me, and I think you'd have a much better idea. So this is in terms of the point where I was talking about external communications from ship to shore, and then the question was in terms of internal communications within the ship. Can you talk about the 5G wireless setup within the vessels?
So typically today we need to deploy a Wi-Fi network on board the vessels, and then that would go through your SD-WAN solution, and then that's how you would get your multiple modes of communication out board. Because 5G signal can deteriorate on various different decks on board the vessel. So obviously you come into the engine room, you're going to get less signal. So it's all driven via the Wi-Fi signal on board. So you're not getting 5G to the end point device, you're getting Wi-Fi to the end device, and then 5G is coming out from your central distribution point.
I'm glad you clarified that, because I thought it was the case, but I didn't want to make a fool of myself on the call just by assuming it was. If there's any other questions from the audience, please fire them through. But I think our allotted 1 hour period is over. So yeah, thank you very much, guys. Really enjoyed listening to you both. Yeah, I think that's it. Thank you.
Thank you very much. Thank you very much.
Take care, everyone, and thank you very much for listening.
Bye-bye.
Thank you. Bye-bye.